This video has been made possible by Hey Gears. If you've watched the previous videos following this project, you'll know that I'm documenting the process and workflow in creating the wireless charging stand. The next stages to this will be creating a matrix mold for the front section so I can do some resin cast versions and also some batch printing of the other components. I'll be printing the shells and the components on the Hey Gears Ultracraft Reflex printer. The mould shells will be printed from their PAWR10 resin, which is a strong and durable resin, ideal for something like this that'll see some heavy usage over time. I'll switch that out to the PAU10 resin when it comes to printing the components. So kind of just to sum up where I'm at with this, I've backtracked and changed some of the processes to make these. Because I've done that, I've had to do some design changes to accommodate, but it's all in an effort to try and improve the efficiency of making them. So before, the stand was made up of 11 pieces, which all slotted together, magnetically attached. Design-wise, everything worked and went together well. However, as I got to the point where it was time to actually make them, it dawned on me that there's a lot of components per finished piece for me to manage on my own. It'd be so labour intensive to create them and just not practical from that point of view. Just because I design them as individual pieces doesn't necessarily mean that I have to make them that way. So I went back and I've combined as many pieces as I can just to try and slim everything down. So I've now gone from 11 components down to 6, as well as reducing the amount of hardware needed to assemble them. So this is the version from the previous video. So everything that makes up the back, which is 4 pieces, will now end up being one solid cast part. The charger holder and the magnetic version will have the insert trim attached to it. That means that I don't have to have the little magnet holder that was behind there. That's another part taken out. The front will remain the same, other than just a slight functionality change to accommodate for all these other changes. Now that the shells have finished printing, I can make a start on prepping them by removing all the support material and washing them in the wash station. Once clean, I can put them in the curing oven to run them through a full cure cycle. I've also printed the masters to take a mould from. I've taken a slightly different approach with this mould in the way that it's made. That's why these masters have other elements around it built in and look the way they do. Once these are cured, I can start prepping them by sanding off the remains of the supports and gluing in some M4 nuts. This hardware is in place to secure the 2 mould shells together during making the mould and casting the parts. So the approach with this mould was to try and reduce the amount of steps needed in actually making the mould, but also to have a system where if I wanted to make multiple versions of this mould to run at the same time, it's quick and easy for me to do with minimal setup. So I've made a mock-up of what I would normally do with a matrix mould with clay. So this is at the point of the first silicon pour, just to show how these two systems differ and what steps I've been able to remove to make this process a lot quicker. So as we're looking at this, I've clayed up this inside this back shell. So at this point, I take the other shell, put that on top, pour the silicon in to make the first half. Once that's cured, flip it over, remove the first shell with the clay, but leaving the master inside the silicon in this half. Once that's cured, I can then put this side on, which will form another cavity inside, pour the silicon in, and then at that point you've got your complete matrix mold. What I've done with this other way of doing it is I've incorporated the clay and the master into the same footprint as the shell. So these are essentially the same thing, but I've just not had to do all the clay work, getting all of this nice. So I can take this piece, put the shell on, pour into that, and then that's one side done. And rather than doing the whole flipping over thing, I've got the opposite side that uses the opposite shell. So I can put that on there as well. That'll give me the other side, which I can run simultaneously as well. So I can do this in one pour. Once those are done, I can then remove these, put the silicone inside these two, close it up, and then again, that's essentially my mold done. The advantage of this is also the fact that if I want to make multiple molds, all I've got to do is just print more shells. There is one drawback that I've kind of thought of that might happen, and it's basically just some excess flashing, which isn't really a problem, but the reason I've thought it might happen is when you pour like your second silicone pour onto the first, it takes the impression of the silicone itself. So those two halves are just going to mate precisely together. With this system, the fact that you're making two halves that never touch, they're technically not an impression of each other. So alignment won't be a problem, I don't think, because the CAD models all line up, everything locates together. I think it's just the way they locate together might cause some excess flashing. I genuinely don't know. We'll find out. It's something I've been wanting to do for a while, this sort of system of making molds to make molds. So it'll be fun to see if it actually works as well as I hope it would. Before I pour this mold, I need to set off a batch print for the other components. The ideal workflow is to have the printer running while I'm busy making the molds. Then, as soon as the print is finished, wash and cure those parts and get another batch print going. Ideally, the printer should be continuously running. The amount of prep is so minimal with these. All I need to do is glue in what will become the pour hole for casting the resin into the back, which is a piece that I've also printed. Then add the sprues for what will be the air holes through the mold using these 2.5mm dowel pins. So I've really tried to think ahead with all the features that I've added to the mold and the master, just to try and make the mold making process as straightforward as it can be. So rather than gluing the cotton buds on like I normally would, I think this dowel system is going to work a lot better for efficiency, and it's just a clean method as well. So it's probably something I'm going to use moving forward on all my other parts. On the front side, you've obviously got the dowels as well, but those aren't air holes. So this is like the forged carbon mold that I did. So these will create a void through the silicone like air holes, but what they're actually for is so I can put an M3 machine screw through the shell and put a threaded insert on the end. So when I pour the resin in, the resin will go around the insert, encapsulate that in, and again it just saves me a step in post-processing where I'd have to glue that in. Before I close these up, I can apply some mold release to both sides and the insides of the shells. Then locate and secure them together with the M4 machine screws. The prints align well and close up tightly, so I don't think I need to worry about any silicone leaking through at the split line. I've also applied some filleting wax to the 4 dowel pins that come through the shell, just to ensure they stay in place. So this mold's very similar to the mold that I made in the last video. So I've propped it up at an angle, putting this corner at the lowest point, which is where I'll pour the silicone in, and this corner at the highest point, which will be the last exit point for all the air inside the cavity. So when I pour the silicone in, it'll come up the mold at this sort of angle, coming out of these air holes as it goes up, and then it'll converge at that last point. So having that at the highest point just stops the chance of any air trapped between the silicone and the underside of the shell. The silicone I'm using is a Shore 28A Edition or Platinum Cure silicone, mixed at a 1:1 ratio. Because I designed the silicone mold as a 3D model, I was able to look at the model properties to see the exact volume of each cavity. enabling me to calculate the amount of silicon needed. I always like to add some extra, just to account for the residual silicon left in the cup after you've poured. I'll give this a thorough mix, making sure I scrape the sides and the bottom of the cup, then I'll degas it. This silicon is relatively low viscosity, so doing a stretch pour where you pour a thin stream from a height will collapse a lot of the bubbles in the mixture if you don't have a vacuum chamber. It's a method I used when starting out when I didn't have a vacuum chamber, and it's proven to work really well. I'm pouring this in at a relatively slow rate. If I was just to dump it all in, that will just increase the likelihood of getting air traps. I want the silicon to flow freely and slowly through the mould, finding its own way all the way up to that last air hole. As the mould fills up, I can block the lower holes with the filleting wax to stop them overflowing. Now these are done, I can wait for them to cure. So while I'm at this stage, it makes sense for me to get this mould poured. So this is a multi-cavity mould, which is essentially 4 masters built in. It's very similar to the other two, where it's a mould to make a mould. All I have to do with this is pour silicon in, and then that's done. I can just take that out and just keep doing that based on how many molds I want to run at the same time. So functionality wise, this mold's exactly the same as the previous rigid printed version. So it's still got all the same features with the locator points for the rigid piece that goes in. To achieve the finish I want on these parts, I've shot blasted the entire piece, same as I did on the original mold, which will give me a nice grainy finish. After degassing the silicon, I can start pouring it in. I'm only partially filling the mold to a point where the silicon is covering the details on the master. Usually at this point, for something with fine details, I'd get a small paintbrush and brush those detailed areas, essentially dislodging any air trapped in those details. In this case, I'm going to put the entire mold in the vacuum chamber, achieving the same or, if not, a better result. Once that's fully degassed, I can take it out, fill it up to level, and wait for that to cure as well. As I'm waiting for those to cure, I can remove the first batch print and start prepping them. I'm only prepping these as far as the curing stage, so supports removed, components washed and set to cure. I want to build up a bit of a prep pile so I can tackle the sanding of the printed and the cast parts all in one sitting. Now these have cured, I can start demolding. This is a case of driving a wedge between the two halves, removing the two masters and pulling all of the dowels out. It looks like the pour's been successful without any air traps. I can now turn these over and trim off the excess silicon on the back of each of the shells. Then remove the silicon and trim off the excess from the air holes so it seats back into the shell properly. Now I can move over to the multi-cavity mould. Degassing the silicon inside the mould has worked really well, as all of the small text and details have got 0 air bubbles. Before I screw the two halves together, I need to insert the machine screws and the threaded inserts. I'm filling the threaded inserts with filleting wax to act as a barrier so no resin can get inside onto the threads. So in the exact same way I did for the forged carbon mould, I can push the machine screws through the silicon, revealing a small portion of threads on the inside of the mould. Then I can thread the inserts on. The machine screw will push the excess wax out of the back of the insert, so once they're all in, I can cleanly level that off. I'm propping the mould up in the same way as I did when pouring the silicone for the exact same reasons. I'm casting these parts using polyurethane resin that I've added black pigment to. I'm also adding 10% milled carbon to part A for additional strength in the part. This resin doesn't strictly need to be degassed due to its low viscosity. However, when I use milled carbon, I will always degas as part of the mixing process before adding part B. If it's not mixed thoroughly, you can end up with very small clumps of carbon and part A that didn't mix into part B. Usually I'd put this in the pressure pot up to the point where it starts to gel, but I want to run a test just to see if that is needed as part of this workflow. While I wait for that to cure, I can go back to the printer and run another batch. These parts that are finished are the inserts that go into the multi-cavity mould to be overmoulded. There's actually no prep work needed with these. I still need to wash and cure them, but as they're being overmoulded with resin, they don't need the support remains sanding off. The resin I'm using for this again is a polyurethane, but it's a flexible version with a Shore rating of 30A. I'm adding my black pigment to part A, giving that a good mix, and then adding part B. This resin again doesn't need to be degassed, but I would recommend it as it vastly improves the structural properties of the cast part. I would usually put this in the pressure pot as well because of those fine details. But as this resin takes a while to gel compared to the other resin, I'd be waiting a while before I can cast anything else and use the pressure pot. So that could potentially slow down the entire workflow. As degassing the silicone for this mould works so well, I thought I'd try the same process with the casting by partially filling the mould, degassing to get the air out from those details, then fill the rest up to level. I think making some sort of jig for the vacuum chamber and for the mould would be beneficial, especially if I've got multiple moulds, because that means I can stack them. I also think I could finesse this a little bit better if I poured into the mould on some precision scales, just so I can get the quantity consistent between each of the parts. While I leave that to cure, I can turn my attention back to the other mould. I need to clean up the slight overflow of resin, then I can back off the machine screws that are holding the inserts in. Then I can open it all up and start demoulding. All looks well apart from a tiny air hole around the opening in the middle of the part, so maybe they do want curing in the pressure pot. So I'm really happy with how clean this has turned out. Obviously I was expecting some excess flashing with the method I used to make the two mould halves separately, but it's just absolutely perfect. It's so clean. I think just some 400 grit around the edge and that'll be done. The inserts have worked out well. I was again expecting some excess flashing between the insert and the silicone, but they're just sitting perfectly. I mean, I've never done threaded inserts in a silicone mold before. I did them in the forged carbon mold, so it's the same concept, but no leak through the mold either. So it's all worked well. Having the printer running while doing all these molds has relieved me of so much additional work. I've said it before, but having a printer that I can set and forget without having to check up on it is just invaluable, especially in a low volume production workflow. Now the base pads have cured, I can start the demoulding. The finish that the shot blasting has put onto the master, which is subsequently onto the part, is such a nice consistent grain, and all those details have turned out perfectly as well. I designed the small tabs with a groove so I can just snap those off flush. Then it's just a case of running a blade round the edge to clean up the excess. At this point, I've gone ahead and created another set of molds so I can start catching up with the amount of printed components I've got so far. Then I can make a start on all the prep work. This is really a case of sanding all the flat surfaces with the orbital. I'm using a 400 grit Abranet pad, then going around with some 240 grit sandpaper to get the rest of the support remains off. So at this stage, I've got all the parts prepped ready for paint. I am going to hold off for now. I want to cast a few more front pieces just to get the numbers up to match what I've got for the printer, and then just paint all those in one sitting. Looking back at the workflow of this section with those systems in place, it's just made things so straightforward, and it's definitely been worth putting the extra time up front to develop all of that. Just that little bit of extra time will forever make the whole workflow really straightforward and easy. That in combination with having the printer running, I mean, that's invaluable really. The consistency, I don't have to babysit it, and just having that running while I'm working, it's just a really, really good setup. Moving forward, I need to make the mold for that, for this back section. That's got a tube that goes inside it. It's another thing that I'm able to try with this project. It's kind of like an overmolding thing. The cable needs to pass through it still. If it's a solid cast piece, obviously I can't do that. So the idea is to 3D print this tube that slots into the mold before I cast it, and I can pour the resin. So essentially it encapsulates that tube and will leave a cavity for that cable to run through. So yeah, I mean, this whole project has enabled me to do these ideas I've had but never had the application for. So I've really enjoyed it so far, trying these new things. Probably going to make some jigs. I think I mentioned it before with the base mold, with the pads, the multi-cavity mold. Make like a stackable jig so I can put it in the vacuum chamber, and also because I want to post-cure them or accelerate the cure of those, put them in there as well as a stack. So jigs is definitely on the cards. Forged carbon mold, I need to revisit that. I mean, the idea moving forward with all of this is to have sort of a base model of a full black version, and then have all these different variants of the front piece. I think that'll be a nice way to do it, so then I can just do different versions, different materials. Now I've got the castable mold. Anything that I can cast into there. So concrete, for example, I think that'd be a nice one. Transparent. It's just opened up a lot of different options for me to do. So I need to get the numbers up, work on that mold. Jigs, which I am actually really looking forward to making jigs. It's another set of problems to solve. If you're thinking about picking up a reflex printer, my code is RTA Fabrication. Currently, there's $200 off. So if you're thinking about it, now's the time to do it. And yeah, just move forward with the project.